Okay, so we're now on to 3D. I'm going to do a little bit of an explanation of things just for those of you that are kind of interested as to like why things work. So lots of things in math, there's reasoning behind it. This is one of the reasons. So we're going to talk about one of the reasons why the sum of the interior angles of a triangle is 180 degrees. So we're going to talk about proof a little bit later in the next unit, but basically in a proof you're given a piece of information, a fact that you know. So this says that xy is parallel to BC or CB. And what you're trying to do is you're going to try and show me why the measure of angle 2 plus the measure of angle B plus the measure of angle C is 180 degrees, okay? And you're like, oh, well, it's because it's a triangle. Well, say you didn't know that, okay? And so why would that be true? So any triangle that you draw, you could actually draw a line that would be parallel to one side that would go through the vertex of the other side, or sometimes it is the other side. So this would actually be true for any triangle. This is just a specific example. So we're kind of talk about why that would be true. So first thing I look at is the 180 degrees. And one of the things that I notice on my diagram is, well, I know that a straight angle measures 180 degrees, okay? So I'm like, well, where does that 180 come from? Well, I know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees because they are on a straight line. It's a straight angle, and a straight angle measures 180 degrees. So they're in a linear pair, but part plus part is whole, something along those lines. So the question is, how did these other angles come into play? How does this angle 1 come into play? And why were you given that these lines were parallel? Well, you were given these lines were parallel. Well, from the last unit, you should know that, well, the measure of angle C and the measure of angle 1, so angle C must be congruent to angle 1 because they're alternate interior angles on parallel lines. You also, another little piece of information is we have an alternate interior angle on the other side. We have, well, angle B must be congruent to angle 3 because those are alternate interior angles on parallel lines. So when I'm looking at this, well, I know measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180. Well, if this angle is the same as this angle right here, then I can replace, well, angle 1 is the same as angle C, and angle 3 is the same as angle B here. And so essentially, the reason why the sum of the measures of the interior angles of a triangle is 180 degrees is because these three angles right here form a straight line and a straight angle. So I think that's kind of interesting. So first thing, when we talk about triangle sum theorem, I just proved to you that that's true, that the sum of the interior angles of a triangle is 180. So there we go, is 180 degrees. So for this one right here, the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. So that's triangle sum theorem. Just as a little quick explanation. You can fast forward through these, but I think these are kind of interesting. This right here should be triangle. Just a formatting issue with Word and the software that I was using. So for the next one, the measure of A plus the measure of B is equal to BCD. So let's kind of look at that right there. So the measure of A plus the measure of B must be equal to this one right here, C. Okay? So how does that come about? Now, the first thing I want to do is I want to talk about this right here. These two right here are called remote interior angles, okay? And remote interior angles are angles that they're non-adjacent, adjacent. Non-adjacent angles to the exterior angle. And they're called remote because they're far away. So we have this angle here, and then this angle and this angle are kind of far away. So first thing is, when I look at something like this and I'm trying to prove that that's true, one of the things that I notice, well, I start writing the things that I know. I know for sure that the measure of angle A plus the measure of angle B plus the measure of angle ACB is equal to 180 degrees. So I know for sure that that's definitely true because of triangle sum theorem, the last thing that we proved. I also know that this angle here and this angle here, which I've already talked about, ACB, are a linear pair. And so the other thing that I know is the measure of angle BCD plus the measure of angle ACB is equal to 180 degrees. So these two angles plus this one are 180, and this single angle here plus this one is 180 degrees. So what must be true about the values of these angles? Well, wouldn't they have to be the same? Like if this quantity here plus this quantity here is 180, and this quantity here plus the same quantity is 180, then these two must be equal to each other. So that's where this comes from. The measure of angle A plus the measure of angle B is equal to measure of angle BCD. The sum of the measures, these are called remote interior angles. And this is an exterior angle. So the sum of the measures, I should have S here, measures of the remote interior angles is equal to the measure of the exterior angle. And that just says the measure of angle A plus the measure of angle B is equal to the measure of angle 1 in this case. Okay, so I have just two more things to explain, and then I'm gonna make a separate video for the practice. So the next thing is called base angles theorem. Base angles theorem says that if two angles of a triangle are congruent, so basically if angle A is congruent to angle C, then, and this actually makes sense with what we did before, then side AB must be congruent, or side, AB must be congruent to side CB. Okay, because we talked about the bigger the side, the bigger the angle. Well, what if the angles are the same? These two angles are the same, so these two sides have to be the same. So if two angles of a triangle are congruent, then the opposite sides are congruent. And then the converse, the reverse, okay, converse means reverse, okay, says if two sides of a triangle are congruent, so let's say AB is congruent to CB, then what must be true is then angle A must be congruent to angle C, which is part of the reason why an equilateral triangle, since all of the sides are the same, all of the angles have to be the same, because there's that direct relationship between the angles and the sides. And you guys will see even more so when we are doing trigonometry. So the two sides of a triangle are congruent, then the opposite angles are congruent. So I'm going to end here, and I'm going to have a separate video for the practice problem. So this is the foundational stuff. You should be able to do the practice problems with this foundational information. But if not, then we'll go to the practice, and you can